Hello, I got some very good questions from you. I think I'd like to go over this with you. Well, how do we see the relationship between a function and its derivative? Okay, first we understand in our previous studies, we understand when we have a mx plus b, right? This is a line equation. When the slope is positive, when the slope is positive, the line is increasing. When the slope is negative, the line is decreasing. It's decreasing. When slope is 0, right? Well, the line is a constant. The line is a constant. It's a horizontal line. Okay. Well, in later chapters, we will learn, other things about what if it's a curve, it's not a line. But since we know derivative is the slope of a tangent line, right? You see, this is the curve, and this is its derivative. So one of the things we will learn soon, okay, now we can also tell is that when the curve changes from decreasing to increasing, if this is a continuous curve, and this is one, and then there's a plateau, there's a horizontal line, and this is the moment where the slope is 0, okay? And before it reaches 0, right? And if you draw these tangent line, say I draw a tangent line, this tangent line is decreasing. Slope is negative. It's decreasing. So we have a sequence of decreasing tangent line, and the slope are negative. Slopes are negative, meaning that at a point A, right, the slope is going to be 0. So this is the curve of derivative, and this is the curve of the function. So derivative, this is the place that m is 0. Before point A, right, the slope are negative. So you can see all of these tell us the slopes are negative. Okay, these are a negative slope. These negative slope corresponds to the decreasing tangent line and their slopes. And passing this slope equal to 0, the curve start to increase. Increase that you have positive slopes. Positive slopes, so these are positive slopes. These are positive slopes. Until it hit, and then you can see it reaches another plateau, right? So, and in the process, the slope is getting, all of these slopes are positive. So this slope, right, tangent line slope, and the next tangent line slope, and they are getting, they're all positive, but they're getting, they peak at a turning point, is usually called inflection point, and then they start to slow down. So this is a piece of slope, so it's going to go down. So at the next plateau, you have a slope equal to 0. So the idea is, in this case, is that you're going to find all the places where the slope is 0, and you mark those places, right? And so you have a few turning points, and in between usually it's just up and down or down, up, because in this piece, it just keep going up. The slope is going to be staying positive. So here is the general principle. These are the general principle, and that is our, our guideline. Okay, the guideline is that when the derivative of when the derivative of the function is negative, is decreasing. Okay, the curve is decreasing. The curve is decreasing. Okay, like in this case, the curve is decreasing, so the slope is going to be beneath x-axis. Those are negative. Okay, and at the point where local minimum or local maximum, these are local minimum or local maximum. In the future, we'll learn them. They're possibly, you know, they're the minimum we can find, right? Those are the points we can identify, and in between, and we can determine the you know how it goes. And some, if for a continuous function, we can use the properties of continuous function. So when the derivative is a positive, the curve is increasing. Okay, the curve is increasing. Is increasing. Increasing means it goes up, so the slopes are positive. Okay, so it's just a matter of how much it increases, right? It keeps going up, 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 and slowing down, but still positive slope, like in this piece. And between B and C is decreasing, right? It's decreasing, and it's slowly like going steeper, and then gradually, you know, slowing down. So you can draw some tangent line to see that for our consumption, right? For example, you can, this is the tangent line, obviously the slope is negative, right? You can keep drawing this, the slope is negative. You can evaluate the values of these points. You can evaluate this if you have a concrete point between B and C, and just plot those points, and that's how we can get the purple curve. Okay, so these point F is plotted point by point, and its derivative can also be plotted point by point. But in general, it's much easier that we start with the slope equals to 0, as pretty soon we're going to learn how to find derivative as a function, and then we can work with that function to find the x-intercepts and learn what's in between. I hope this answered your question, and we will learn more of it. And now, what if the derivative is 0? Right? So we covered less than 0 curve decreasing, greater than 0, the curve is increasing. What if the derivative equals to 0? Okay, f prime equals to, at a certain point, equals to 0. These numbers, as we will learn in chapter 4, they're called critical values. Critical values. Okay, so these critical values, so these points are the critical values. We have it here. In chapter 4, we will learn about it, and these are the candidates. Okay, they're not always the local max, local min, but they are the candidates for local max, local min, where, you know, the curve reaches a local minimum or local maximum. So that's how you can see we find the slope where it's equals to 0. Okay, so that was a brief answer. I hope it helps you to at least have a glimpse of to these issues. And as we enter chapter 3 and chapter 4, and more of these will be reviewed to us. But I really appreciate this question, and that means you are thinking about it. And I strongly encourage these kind of questions. Thank you for watching. Hope this is not too long.